What's going on, everyone? Steven here from techmaker.tv. So this past week, I had to do some updates to some records in a pretty big database that I built several years ago. It's got tens of millions of records in it, and each update was fairly time intensive. I don't know exactly how long each thing was taking, but there were database queries involved and then actual math and so on and so forth. So I was running this task and I don't know exactly the number of records I was hitting or whatever, and that's not relevant for the purposes of this discussion, but running this thing was taking an hour or two, and I had to run it several times. So for the better part of a day, I was just running this task. And so I found myself kind of going, man, I wish I knew how long it would be before this thing is done and how many records are left and so on and so forth. And so I looked around and found some open source tools that help with that, which is great. And that got me curious about how these things work. And so I thought, well, it might be kind of cool, me being me, to experiment and see if we could work this out together and build something that kind of does this. Now, I'll link to some tools down in the description that are obviously more fully featured that you can go and work with if you want to do that. But if you want to get a sense for how these sorts of things work, this is the spot for you. So I thought it'd be cool to kind of throw this into one of these Hour of Ruby style episodes, and we'll just see where we end up. I don't know if it'll be exactly an hour, but that's kind of how we've decided to brand this discussion. So this will be episode 2 in that series. So before we jump in, as always, if you like this video, be sure to give it a thumbs up and subscribe to the channel if you're new here and you like this kind of content, because we're putting stuff out pretty much every day, but certainly a lot. So anyway, with that said, let's go ahead and jump in. Also, I just got a new microphone. I'm trying to upgrade my my recording setup here and get a little more professional. So if I sound a little bit too much like a radio DJ or something like that, you know why. Or if you were surprised that it sounds a little bit different or something like that. If you have any issues with volume or anything like that, throw a comment down below and I'll see if I can make some adjustments. But anyway, here it goes. So I've created a file over here called progress.rb, and I just kind of want to work through the problem in parts. So let me write a little bit of code here to illustrate the first problem that I'm imagining. So let's say that we have a variable x. I don't want my caps lock on. What is happening? X equals, let's just say 5. And then let's say x dot times do n. And then let's just write out like some kind of trivial sentence. So we'll just print or maybe puts the number is now in. Okay, and then let's just run this ruby progress.rb. And so basically you see we print out 4 things, or 5 things rather, starting with 0, and then they all go on individual lines. So this is kind of how I was sort of roughing this in the other day when I was doing my own task initially. And so you end up with just long streams of server output, basically, every time something's updated or whatever. And what I got curious about is you see these kind of like terminal console tools, command line tools that they update the text in place, and I had never built anything quite like that. And it turns out it's actually not really all that hard. So first of all, if we switch this to print, it won't create a new line. It'll just put them all on the same line. So you get them all jammed together. And we can add a carriage return here with \r. And this, and honestly, I don't know why, but this will magically swap the text. So, and actually to illustrate this, if we run it, you won't even see it. So let's just add a sleep for 1 second in here. So watch this. So if we print this out, it's going to say number is now 1, 2, 3, 4. So that's pretty cool, and that's basically how that works. So I think what I want to do is go ahead and put the text in here that I want to print each time. And from there, we can sort of back our way into filling out all of the features, essentially. So what I want to say is something like parentheses, and I want to say like 10% complete, maybe. I want to give it like the number of items remaining or something like that. So we'll say like 10 items remaining, or maybe 10 items left, and then like 200 seconds remaining. Something like that. Not 100% sure. That should get us in the direction we want to go, though. So first of all, let me spell remaining correctly, if I can. All of a sudden, get paranoid that I don't know how to spell anymore. And we also need to say this is really not going to be precise, right? So it's going to say something like about 200 seconds remaining. Okay, so let's see about how we can get all this working. So the number of items left and the percent complete should be pretty straightforward. So first of all, let's put these in variables here. So let's just say items left equals, and what we'll do, and again, I'm going to kind of keep the code ugly for now because I'm not really sure how all of this is going to fit together in the end, and so I don't really want to do anything fancy. I just want to kind of do super obvious code here. So we'll say I equals 0, and the first thing I'm going to do is say I equals I plus 1, and the number of items left is, let's say, x minus I, and then let's just kind of see if we can get this to rock and roll using our variable here. So we'll say items left. Okay, so let's run this again and just see what happens here. So we'll get 4 items left, 3 items left, 2 items left, 1, and that's it. Cool. So we have this little bit of text hanging out, though. I'd like to maybe put something at the end. I'd say puts finished, and then X items processed. Maybe something like that. So let's run it one more time and just get a sense for how that looks. 2 items left, 1, and finished, 5 items processed. Okay, so the next thing to do is calculate the percent complete. So what I'm going to do basically here is just say percent complete equals, and then we'll say something like items left divided by X, right? So that's our, so if there's 4 items left, and actually no, that's wrong. Sorry, excuse me. It should be I divided by X, and then we will grab that, and I'm gonna go ahead and stick 100. Sorry, 100 here. So normally, like if it's 1 divided by 5, it would be 20% complete, but 1 divided by 5 is going to give us 0.2. Also, we need to convert this to F so that we can do the division confidently with a floating point number. And then we'll just round this. Okay, so now let's just copy this thing and paste it right here. Percent complete, and let's run it again and see what happens over here. So 20, 40, 60. Yeah, cool. So once it's done, maybe we actually ought to replace this so that it's not giving us this finished X number of items processed. Maybe we should actually keep our same text here. And just make this say 100, just to kind of keep it uniform. This might look nice. And then 0 items left, and then 0 seconds remaining. Something like that. Let's run that. Just kind of getting this to look the way that I would like. And we've got a weird thing going on here with the text at the end. So I'm going to have to figure that one out a little bit later. Not 100% sure how to do that, honestly. This isn't really my This sort of terminal application isn't really my specialty, but I like doing it to sort of learn things. So anyway, we will learn it together, but I don't know how to get rid of this ending ng back there right now. So I'll have to check that out in a bit. But for now, I like the flow here, so let's keep going. So we're gonna get on to something a bit more interesting now. So we're gonna require benchmark. So I want to actually figure out how to calculate the time remaining. And this is going to we're going to start really simple and build up to something that's a little more complicated. But benchmark is part of the standard library, if I didn't already say that. And what I want to do is basically say this. I'm going to say measurement equals benchmark dot measure do. And we'll sleep for a second on each one here. And this sleep one is basically supposed to simulate doing some work, okay? So all the rest of this is really part of the progress tool that we're developing. This measurement, this sleep one is actually where the real work would be happening. And that'll become more important a little bit later. Okay. So for now, let's see, how should we do this? So if we just assume for a second that every time we go through, the measurement is the same each time, which because we're sleeping for just 1 second each time, it should be basically the same. But basically, if we assume that each time we loop through, the amount of time is the same, then what we can do is just multiply the items left by the measurement and get the time remaining in seconds. So what we can do here is say time, let's actually do it like this. Let's call it what it is, seconds remaining. And we'll do items left times, and we'll say measurement. And really quick, let's actually crack this open. And let's have a look at this measurement. So we'll say binding.pry here. And let's run this program again here. So we should get stuck pretty much right away. And let's have a look at measurement. So measurement, as you can see here, it has several different things in it, but the one that I'm interested in is real. So my understanding is that is the real amount of time passed. And so it's giving us 1.00079 something seconds, basically. Which makes sense, I think, because it's actually supposed to be sleeping for a second, right? So we can actually, I don't think we need to be more precise than seconds, not 2s, 2I, or no, sorry, let's do round. So we'll just round it and get the number of seconds. So let's do items left times measurement dot real dot round, and that should give us the number of seconds remaining, and we'll have a look at that. So now what we can do is copy this again, and then down here we'll just paste this in, and that should be 0. I thought I changed that earlier. Maybe I did and I undid it for some reason. Okay, so let's quit out of here and clear my console and run this again. I don't think I didn't want to save that. I think I've got rid of my pry. Okay, let's try this out again. 4 seconds remaining, 3, 2, 1, lift off. All right, before I forget, let me go ahead and remove the tilde down here because it's actually 0 seconds, not almost 0 seconds remaining. And let's see what to do next. So what I want to get done next is I want to fix this so that it's not hard-coded to just sleep for a second. So basically, if I can go down to the bottom and maybe write some pseudocode, what I would like to happen, so let's think about the situation where we're using this. What we want to do is have some code like this. So things dot each do thing, and then we'll say like thing.long running task or whatever, and then end. And what we would like to do is have something that's like progress equals progress.new, and then down here we would say like progress.track, and then pass in this as a block or something like that. Something like that. So, and then maybe this actually needs to take in the number of things, something along those lines. I'm going to comment all this out. So that's the direction I want to go in. So let's see if we can get anything that approximates that together. So I'm not going to touch the code at the top just yet. Actually, you know what? Let's open a new file. Well, no, I want to call my file progress. So let's rename this one. Let's rename this and be runner. And then I'm going to create a new file called progress. And I'm just going to create a class called progress here. And then we're going to give it an initialize. It's going to take in items count. And then we'll just set that to an instance variable. Okay. And obviously make it an adder reader. Okay, cool. So what else do we want? Well, let's just assume for a second, and I'm kind of getting ahead of myself here. So you could do this in a very iterative way, and maybe we'll try to basically push it into this existing code. Not exactly sure how we're going to do this yet, but I'm just going to assume that I need to write these variables into methods. So we'll say items left is, well, let's see. It'd be items count, right? Minus items remaining. No, what is that? We have I, which is just a loop counter. Maybe we call that the index, not the I index. Okay, and then maybe we need to come in here and say at index equals 0. That's what we started off with, right? And let's make that an adder accessor index. And let's see where we go from here. So seconds remaining. Let's do that one last. Percent complete next. Percent complete is going to be 100 times the index divided by x, which x is our items count. So we'll say 100 times index divided by items count, like this. And then we'll just do round, and that should give us our percent complete. Okay, so let's see about how is this gonna work. I think what's gonna have to happen, so we kind of down here in the bottom, we have this track method, right? So let's write this method track. So track looks like it takes a block, right? And track basically does this. It says it's going to do all of these things, or all of these modifications. So let's copy all of that and put that in track, and then kind of work our way backwards. So we'll say index equals index plus 1. And let's actually make this a method. We'll say index.increment, if I can spell increment. Maybe give it an exclamation point to say that we're modifying the state with this method. So we'll write a method, and actually I need to do it like this, increment index, because we're just going to write it right here. So we'll write a method increment, and then we'll just say index, you know what? I don't even need to pass that in, really, do I? So I could just say index equals index plus 1, something like that. Maybe to be more clear, we'll call that increment index. So we'll do that first. Then items left is a method now, right? So that should work. Seconds remaining. So we haven't really worked anything out with this measurement thing. So let's comment this one out for just a sec. Percent complete. Percent complete is done. So I think the last thing we need to figure out is this measurement business. So let's go up to the top and let's require benchmark. Okay, so I just commented this code out actually, but let's come down here. I did something that I shouldn't have done, but it's okay because I have all this code over here still. So let's grab this measurement equals and let's put that down here. Now, should we put it above or below the increment? It looks like it's above here, so let's leave it above just so we keep the same behavior. So we're passing in a block, right? So what we can do here is just say block.call. So we don't really care what this code does, right? We just want to call it. And now we have the measurement here, so now we can get our seconds remaining. And let's go ahead and bump that into a method as well. Seconds remaining. And let's go ahead and like create this with, we're gonna need to pass in a measurement here. So let's grab this, put it up in this new method we just wrote. So items left times measurement.real.round. Okay, so now the only thing left is that we need to pass in measurement here. Okay, so basically now track is accepting a block and it's doing benchmark.measure, do block call, increment index, so on and so forth. Okay, so let's see about if we want to use this now. So I'm going to comment all of this out except for the final bit there. And let's see about how we can run this. So remember, you know, down here, we had this things.each thing long running task business that we wanted to do, right? So let's imagine that we've got, let's create a new file. We're gonna need something that's like a task, not a task. Let's just call it like a, well, let's call it something super generic, program.rb. And we'll create a class called program. And you'll see why we need this in a second. So basically what I'm gonna do is say run, and it's just going to sleep for 1 second. So, okay, why in the world are we doing all of this? So what we need to do is create an array. So we'll say programs equals an array. I need to fix that. And in here, we're gonna have program.new, 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 and then one more. Okay. So now I want to use my new class. So just to clarify, you know, all this up here was really just sort of working through this with very bare bones stuff. But what we actually want to be able to do is kick off methods and benchmark them basically, and then use that to essentially track how much time we have left. Okay, so, and we're going to have a fair bit left to do to make this a little bit more realistic because the approach we're taking now is kind of naive, but we'll get there in a second. So remember, this is ultimately the goal down here. Things.each do thing, blah, blah, blah. So let's go ahead and uncomment this, and let's say programs.count. I'll move that up. Move this down all the way to the bottom. And now, make sure I put that right in progress, right? So we take an items count, index is 0. All I wrote quite a bit of code here without trying anything, so we will see how that went. But let's say programs I each do program. And let's now say progress.track program.run. Okay? Now, before we get ourselves messed up here, let's make sure we require relative. And I want to do program, and I will do the same for progress. Okay, so let's just see what happens if we try to run this. Ruby progress, nothing happened. Let's see, what did we do wrong? Oh, I just remembered I changed the name of this file. That's what it is. So we'll do ruby runner.rb. So now we're getting an actual problem here. So undefined method plus for nil class. Let's go over to progress and check this out. So we'll say self.index here, and let's try this. So cool, it's working exactly how we wanted. Okay, so we're no longer doing a simulation, so this is actually running the code, so we don't need to do that. I'm pretty happy with this file overall. And program we're going to come back to in a minute. The first thing I want to do, or the next thing I want to do rather, is go ahead and clean up this runner file because it's got a big mess in here that we don't need anymore. Okay, so we'll just get rid of that and get this stuff kind of squared away. Okay, cool. So finally, now we have our thing hooked up, so we can add a few more programs here. Let's add like several more and run this again. Let me clear this up. Somehow I keep hitting my caps lock. All right, Ruby runner. So 8, 7, and we're just gonna count down for a second. So this is looking pretty good in my opinion. I think it's pretty cool. What we probably want to do is handle a little bit more advanced scenario though, because if you're running these sorts of scripts, the probability that each one is going to take exactly, or each item that you're cycling through is going to take the same amount of time, I would say it's pretty low. I mean, it depends what you're doing. If it's like database updates or something like that, and they're all doing something fairly similar, maybe it takes roughly the same amount of time, but I don't think you can really assume that. And I kind of named this program thing here the way that I did on purpose, because technically this code could be handling anything, and just assuming that the program that we're running has the same amount of time as all the other programs is a bit naive. So let's update our program to take in a number of seconds as an initialize, or an argument to initialize. So we'll say a number of seconds, and then we'll just set that equal to an instance variable, adder, reader, the whole thing. And then up here we'll say number of seconds, and I'm gonna set this to a default value of 1, maybe. Okay, finally. Anyway, so now our program shouldn't break, but let's see what happens if we pass in like a 3 and then a 2. Maybe if I can type. Okay, there we go. So let's run this again. So now it's not going to count down in the way that it was before. You're going to see a few sort of weirdness or weird points here. So 21 seconds, 6 seconds, 4, 6 seconds left. So, that may look kind of familiar when you're cycling through some of like the progress of things, and all of a sudden like it's like jumping all around. That probably happens for a whole bunch of other reasons, like changes to your network or whatever. But anyway, so we don't want this to just bounce around because one program took longer than the rest. So let's think for a second about how we could do this better. So what we really want to happen, at least, let's talk through some ideas. So the first idea that comes to mind is maybe instead of just saying seconds remaining and then passing in the measurement, what we're actually going to do is say something like, well, maybe we need to take like the last certain amount of measurements and average them together, because maybe the network slowed down, or maybe the type of thing that we're doing changed all of a sudden, and now the original estimates that we were giving either got shorter or longer or whatever. So basically, I mean, there's probably a lot of ways you could think about this, but it's a little bit better at least to say, okay, let's use a set of data and provide some kind of prediction instead of just whatever the current thing is, right? So sort of like a moving average or something. Like as you move through the data, you're looking at the last 5 or maybe 10 measurements and seeing, okay, how long did those take, and let's use those to predict how long the rest of it's going to take. Anyway, so let's see if we can rough in something like that. I thought maybe it would make sense, just kind of playing back some of the stuff I just recorded. It might make sense to explain why I'm thinking this, because imagine you have 1 million records or something like that. One option might be, you might think that, well, let me just take the average of all of the measurements so far. But if you're looping through 1 million things, you don't really want to be taking the average of those 1 million things every time you loop through, because that's actually going to slow down your process more. So I'm kind of thinking of a simple way just to keep something in memory that gives you a little bit better guesstimate of what's going on, but isn't, trying to actually get the average of everything you've done so far. So let's kind of work this out a little bit, and hopefully we'll see what we're saying here. So if we add another instance variable to the initialize, that's something like measurements, and we'll just set that equal to an empty array. So let's come down to the seconds remaining. What I want to do here is say something along the lines of, if at measurements dot count is greater than 4, and what I want to do basically is say at measurements dot shift, and that's basically going to just delete the first element of the array. Then I want to say at measurements, and I want to just append measurement dot real dot round, and then we need to take the mean of the measurements. So ultimately we're going to have items left times measurements mean, and what I'm going to do here is just say measurements mean equals, and then we'll grab the measurements and we will map over them. And let's see, how do we do this? Map, and I just want to return the actual number, and then we'll actually, you know what, we don't need to map anything, sorry. We just need to do dot reduce plus, and then divided by at measurements dot count, and this is going to have to be dot to f, and let's put this in parentheses. We'll refactor this in just a second. And then let's dot round to 1 decimal place here. And let's give this a shot. So let's run this and see if we broke anything actually, which is possible. So about 8 seconds remaining, 14 seconds, 10.2 seconds. So now you're getting kind of some different numbers in here. Okay, so, and actually, let's move the round down to the bottom here. So we'll say dot round 1 there. I'm just going to run this one more time. And so we're going to get, our same kind of numbers that we had. And you can see that basically the numbers are a little bit more in step with what's actually happening now. So let's do a tiny little refactoring here. You could go crazy, and I don't really feel like doing that right now. So what I want to do is just say, I'm going to write a method here, mean width, and then I'm going to give that a measurement. And I'm going to basically cut and paste all of this there. And we'll clean that up in just a second. And I'm going to say mean width measurement. And basically what this is going to allow me to do is not have to set this equal to a variable so that text won't wrap. And we could in theory like put this all in one line too to make that even like shorter. Why not? So put that there like that. And let's have a look at this now. If we run it again, hopefully it's all still running exactly how we saw before. Certainly looks like it. There's something with the there's something happening with the flow, which I wish I could fix probably. I feel like there's some ordering with maybe we're incrementing in the wrong order or something, but I'm not that worried about it right now. This basically does what I was wanting in the beginning. So now we can actually really change all this up a bit. We could say like 1.3 and 2.6 and 2.1, 0.4, 3, 0.2 or 1, and we'll just leave that. And let's run it one more time. We don't have to sit here and like watch it all necessarily. Actually, I guess I didn't save that properly or something. No, it's doing something. So this is actually an interesting debugging exercise. So it should be, I'm wondering if it's actually rounding somewhere it shouldn't be. So if we look here, measurement.real.round, maybe we just put this in like give that 2 decimal places or something like that. So we don't even probably need to round it realistically. We really only want to round at the display, so we can just leave the native real number. So then we don't even need to convert this to float. Maybe we should leave that just to be careful. Well, no, they're going to be decimals all the time. So we're going to add those up and then divide by the count. So that should be good. So then we really only want to round right there for the display. And I think that makes sense. Are we calling .round anywhere else? Percent complete. That's fine. The percent complete is fine. That's a different issue. Run it one more time. Let's see what happens here. 10.4, 13.7. So now we're getting more like kind of different numbers. Okay, so this looks pretty cool. Pretty happy about this. It's kind of neat. So this is kind of interesting. I mean, it's a very sort of soft predictive analytics in a way, very lightweight, nothing too fancy at all, but it's kind of using a rolling average to predict, basically when this thing is going to end. There's plenty of other ways you could do that, but it seems kind of simple, and it's giving you a little bit more accurate number than just using whatever the last iteration measurement was. So it's kind of what I was going for. I think that's pretty cool. One thing we might want to do is make this so that you have this in some sort of variable. Basically the number that you want to include in your rolling average, so that it could be like a setting or something like that, because this 5 is sort of arbitrary. I just pulled that out of a hat because it's a small number and we're running a small number of things. You might actually want that to be something like 20 if you wanted to get a more accurate prediction based on your data set or something. I mean, who knows? Like, there's probably a way to figure it out, but I'm interested in data science. Unfortunately, I'm not a data scientist yet. So who knows? One day maybe. But right now, I think this is interesting, and hopefully you found this helpful. All of that said, I think that's about it for this episode. I think this was pretty cool for me anyway. So as always, if you like this video, be sure to give it a thumbs up. And if you made it this far, definitely subscribe to the channel, because we'll be putting out more stuff like this all the time. So all of that said, I will talk to you in the next episode.